Hi. So we have Unit 7, Lesson 2. When and why do we write quadratic equations? So we just got done talking about quadratics with the potato launcher and with uh, area of a picture frame. In this situation, we're going to be solving quadratics in some other real world scenarios. So 2.1 is how many tickets? We have this expression 12 times t, I'm assuming represents tickets, plus maybe a $2.50 charge. So this is the cost for a play. Okay, so t is the number of tickets. Said that, right? That's context right there. And be prepared to explain your response to each question. So number one, family pays this much. How many tickets were bought? So I'll go ahead and do that down here. We have 12t plus the 250 fee, right? And they ended up buying $62.50 worth. Now, the goal is to try to get your variable all by itself to get it isolated. So what you want to do is get rid of the constant terms, right? So let's see, opposite of plus 250 minus 250. But just remember the property of equality, what you do to one side, you have to do to the other. So 12t is still there, but you end up getting this, and the opposite of multiplying by 12 is dividing by 12. And we all know that that gives us 5. So how many tickets were bought? 5 tickets. Okay. Number 2 is a teacher. Ended up paying $278.50. And I want you to do that one. Hint, it's very much just like number 1, except your total number is going to be different. So this number is going to be different for you. Okay, so that's your hint. You're still going to be using that though, that setup. So red and bright pink do not work. How about green? Green works. Yeah, that's better. Okay, so yours is going to be a little different. All right, a flying potato again. All right, so we're coming back to the flying potato. So the other day we were talking about launching a potato, and I believe these are different numbers. You still have Earth's gravity, right, pulling down, and your velocity this time is 80. 80 what? 80 feet per second. So notice how I'm breaking apart the context real quick. And it looks like our initial height is 64 feet up in the air. So what equation would we solve to find the time at which the potato hits the ground? So f of t is our output. Okay. Now, here's a different, so let me read this part real quick. Here is a different function modeling the height of a potato. So this right here, f of t, means the height of the potato. And if they're asking uh, what time, right, in which the potato hits the ground, what does that mean for our height? What does f of t have to be, right? And if it hits the ground, we're going to go ahead and assume we're at sea level, and we're going to assume that the ground means 0. So I would be doing this. I'd be doing number 1, and I would set our parabola, which in algebra, or at least in function notation, would be a quadratic, and we're going to be setting it equal to 0. Now use any method except graphing to find a solution. So I'll tell you what, go ahead and try that one. Go ahead and pause the video and try to solve for t. Try to get t equals some number. Go ahead. Okay, so hopefully you've realized how exhausting this could be. Some of you may have subtracted the 64 over. You could have done that. Um, and you could probably try to plug in all these different numbers. Trial and error can work. If you use Desmos real quick, you might be able to see it. So I'll tell you what, I'll give you a couple more seconds to type in that function, just the function, and see what you get. See if you can find when that quadratic crosses uh, your x-intercept. Okay, so one of the things that we're going to be doing in the future is we're going to be using factoring to solve. So that's a little later in the lesson, but I'll go ahead and kind of show what that means. So what do these coefficients or these numbers all have in common? Are they all divisible by 16 or negative 16? What is negative 16, okay, divided by negative 16? 1. What's 80 divided by negative 16? I believe it's negative 5. And then what is 64 divided by negative 16? I believe that is 4. Yes, negative 4. All right, so you can actually factor out the negative 16 from every single term inside your uh, quadratic function. And negative 4, right? Okay, good. All right, so as you can see, the numbers got smaller, which means I factored correctly for my GCF. And again, GCF is greatest common factor. That was something that all three of those terms had in common, the negative 16. Now the tricky part is uh, how can we factor the rest in that's in the parentheses? Um, this is interesting because we took out the negative 16. We know that t times t gives us the t squared, right? We know this piece times this piece gave us that piece. Now, real interesting is there is a relationship between this negative 4 and the negative 5t. Um, what two numbers can multiply here and here to get us negative 4? We know that 1 times negative 4 gives us negative 4, but does 1 minus 4 give us negative 5? It doesn't, does it? What about negative 4 times 1? And I believe an interesting thing has occurred. Let me double check. Hmm. Our answer is not pretty. Not pretty at all. Hmm. So, um, I can see now why they didn't want me to go into detail. This is actually a lesson way further down the road. So, as you can see, I kind of gave you a hint of what was happening, but this one is going to have to use the quadratic formula, which is way further down the timeline, probably week 6, and this is week 3, so maybe 3 more weeks, maybe somewhere around there. So ignore me. All right. I hope you got at least this far. All right, to understanding that piece. Everything else, don't worry about it. Don't stress. We're gonna do that later, okay? But hopefully you use Desmos and you would have seen a parabola, something like this, right? And you would have seen when it would have crossed. Okay, when that would have crossed. So that would have been t equals your answer. So it's definitely going to be a decimal. Okay, so nothing's wrong with that. All right, revenue for ticket sales. We have this expression and this expression right here and they define the same function. Um, and that makes sense because if you were to distribute the p into those two terms, you would get, well, this expression right here, right? P multiplies to both of those. So you get negative 5p squared and 20 times p, or 20p. All right, so at what price or prices would the school collect $0 from the raffle sales? So the function models the revenue the school would earn from raffle sales in p dollars. Okay, so at what prices? Explain or show your reasoning. Okay, I want you guys to go ahead and try to figure out your answer for this one. And the funny thing is, are you trying to plug in 0 for p, or are you trying to set that whole expression that you've received to 0? So go ahead and try to solve that one, and I'll come back to you guys. All right, so hopefully you guys tried, and you would have set them both equal to 0. So number one, hopefully you set one of them. I don't believe it matters. And you set them equal to 0. Um, this one's tricky, right? Um, because if you plug in 0, right, um, for p, you end up getting 0 times 200, which is 0. So 0 equals 0. So 0 would have worked. Okay, if you plugged in 0 for your price for your tickets, right? And it makes sense. If you sold your tickets for $0, you're not going to make any money, right? Right. So that's kind of like, yeah, sure. Now, what about if you sold your tickets for way too much money? All right. How much would that be? So, what could you plug in for P for right here to get 0? 200 minus something gives us 0. That has to be 200, right? So if you did um, p times 200 minus uh, 5p to get you 0, what would this term need to be to get you a 0? 200 minus what gives you 0? And hopefully you said 200. So you can, what can we plug in for p to get us 200? All right, divide by the 5, and you should get negative 40, which doesn't make sense because, oh, we're not trying to solve for the negative because it doesn't make sense. You can't sell a ticket for negative 40. What'd you do? Staple a $40 bill to the ticket? That does not make sense. There you go. There we go. Excuse me. So if you plug in 40, um, you get 40 times the 200 minus the 5p, which is 40. You end up getting 200 minus the 200 times the 40, which is a funny way of just saying 40 times 0, which is 0. So your two answers that would have worked is 40 bucks or 0. So $0 or $40. That would have been too expensive. All right, so number 2, the school staff noticed that there were two ticket prices that would both result in revenue of 500 bucks. How would you find out what those prices are? Ooh. All right, this is an interesting one. So go ahead and number 2, I'll write it over here, and this is for you. Okay, this is a good one. Go ahead and Let's do p times 200 minus 5p equals 500. So how can we solve for that? Okay, um, think about what times what gives you 500, right? We know 5 times 100. We know um, 4 times what? 125? Yeah. So think about all the different numbers you could plug in, all right, that would work with your setup. Does that make sense? So inside the parentheses, it would have to get you 100 or 125. See what number would plug in to get you that 500. So that's a good one to kind of guess and check and see which ones work. Okay. What about 4? What about 5? And just test those out until you get them to multiply to 500. Okay, so that's the end of the video. Have a good day.